Okay, we're working with homework 2.4, motion with a constant acceleration, and we're working actually on number 4. So number 4 has two parts for part A and part B, but before we even start A or B, we're going to just write down our givens, what we're told from the very start. So immediately we're told starting from rest, a boat increases its speed. So we have a velocity that's told to us, kind of. Our initial velocity is what? Well, it's starting from rest. It's 0 meters per second. And then it increases its speed to 4.12 meters per second. So that's going to be our final velocity, is 4.12 meters per second. We're also told it's got a constant acceleration, and that simply means that we can use our 5 equations for constant acceleration. It means it's accelerating at a steady rate. It's not getting faster real suddenly and then backing off. It's getting faster at a constant rate. So now we can start part A right here. And it says, what's the boat's average speed? Well, we're given two velocities, and we actually have an equation for average velocity. That's v average. That's one of our 5 that we derived for acceleration and velocity. Our average velocity is initial velocity plus final velocity times 1/2. I'll put that in brackets there. Times 1/2, or you could say it's the same thing as VI plus VF divided by 2. And if you think about it, that's really how we get the average of any two numbers. For example, if we go into the upper right up here, what's the average of 3 and 5? Well, you can probably figure that out in your head that it's 4, but the way we get that is that we take the two numbers, the two values, 3 plus 5, and divide by how many numbers there are, 2. Well, 3 plus 5 is 8, divided by 2 equals 4, and so that makes sense. And the same thing works with the average of two velocities. You have your initial velocity, your final velocity, and you either multiply by 1/2 or divide by 2. Either way will get you the same answer. So what do we get? Well, we have our initial velocity, which is 0 meters per second, plus our final velocity of 4.12 meters per second. Let's say all divided by 2, I'll write it that way, equals, well, we don't really even need to add the 2. It's basically 4.12 divided by 2. That's 2.06 meters per second. That's our average velocity for part A. For part B, we're given one more bit of information, and so let's write down all of our givens once again. Our initial velocity is 0 meters per second. Our final velocity is 4.12 meters per second. But we're also given a time. If it says if it takes the boat 4.77 seconds to reach this speed, so we're going to make that our delta t, or our change in time, or our elapsed time, 4.77 seconds. So it asks us, how far has it traveled? So what is the change in displacement? What's our delta x? That's what we're trying to solve for right here. Well, it's got a constant acceleration, but it doesn't have a constant speed. So our change in displacement over change in time is going to be like that. Our boat is slower right here. It's got a slower velocity, and here it's got a greater velocity. It's got a greater slope. But the way we can think about our change in displacement over our change in time is really by taking the average, the average velocity. And then we can solve for our delta x. So the average velocity of our two speeds, 0 and 4.12, well, we just calculated right up here in part 4. That's our average velocity. And our average velocity, we know from our little graph right here to be average velocity equals the change in displacement over, oh, I wrote t. Didn't mean to do that. So change in displacement, delta x over our change in time. Well, we know our change in time. That's right here. We don't know our delta x, or we don't know our displacement. That's what we're solving for, but we do know our average velocity from above. So let's rearrange this to solve for our delta x. So it's our average velocity times our change in time is going to equal our displacement. So let's put in our numbers, we'll put in our values, and we'll get an answer for how long it takes for this boat to accelerate. Our average velocity is 2.06 meters per second times time, that's 4.77 seconds, equals 9.83 meters. That's going to be our change in displacement.